All right, today's notes are about graphing systems of inequalities. Goal. Upon completion of these notes, students should be able to graph systems of inequalities and determine if an ordered pair is a solution or not. So we're going to graph the quadratic inequality right here. So I have my calculator on. You should always have your calculators going and keep up and do your problems along with when I do them. Alright, now, y is greater than 3x squared minus 6x. When we graph it on here, we're just going to keep this equal. Alright, and then we're going to type this in. So 3x squared minus 6x. And I always zoom standard. If your window's in the proper setting, you can go ahead and just hit graph. But I hit zoom standard, which is number 6. That gives us a negative 10 by 10 window, which is what I have over here. Now we're going to graph this, and we're going to want 3 nice points as often as we can for parabolas. So I have 2 nice x-intercepts here, and I have a vertex. Now it looks like this is 0, 0, but I'm going to check in case it's a really close decimal. So I'm going to hit second, trace, which is calculate, number 2, which is 0, so I'm finding the 0 or x-intercept. Left bound, right bound is pretty easy. There's 2 ways to do it. I'll show you both ways. I can scroll and move this little cursor to the left. Now, that left arrow is left in x values or lower. All right, the left bound is always a less x value than the where you think your x-intercept is. Then I'll hit enter. I'll move my cursor to the right, and now it's moving to the right, and I want it to move to the right until it's on the other side of the x-axis. All right, or your x value is greater than where you think the x-intercept is. Then I'm going to hit enter, and then I'm going to guess. Actually, I'm just going to hit enter. I don't guess. Just hit enter. And then 0, 0 is what I thought it was. Now, I'm going to plot that in a second. I can remember 0, 0, so I'll go ahead and try to find the other one. Now, I'll do this a little differently. Second, calculate 0. Now, with left bound, right bound, you can just type it in, which is, I think, a little easier. I think this other x-intercept is at 2, so I'm going to type in like x equals 1 for left and maybe x equals 3 or 4 for right. Don't, whenever you're typing the left, don't go across the other x-intercept. So you just got to surround it pretty nicely. So my left bound, I'm going to type in as 1. Hit enter. My right bound, I'm going to go ahead and put in 4. So I know that's definitely greater than where 2 is. Enter. Guess, don't worry about it, just hit enter. And there it is at 2, 0. So now I have 0, 0 and 2, 0. I'm going to go ahead and plot those. So we'll plot those on our graph. So 0, 0 and 2, 0. And then we want to find our vertex. So we'll go back to our graph. And if the graph is opening up, we should expect our vertex to be a minimum. So I'm going to go to second, trace, which is again calculate, which is where a lot of things we do in our calculator are. And I'm going to go to number 3, which is minimum. Now, left bound, right bound, I can use my cursors or type in just like zeros. So my left bound here, it looks like my vertex is around x equals 1, and I should expect that due to symmetry. So I'm going to go ahead and type in my left bound is 0. And then I'm going to hit enter, and then I'll type in my right bound as 2, which is on the right of 1. Hit enter. Guess, I don't worry about. And my vertex is right there, which is at 1, negative 3. So now we're going to type, not type, but graph 1, negative 3. All right, so let's make the shape of this parabola. We got to remember that we use a dashed line. That's the one thing. The calculator looks like you're going to use a solid line, but we're going to use a dashed line because it's not equal to. So the calculator really doesn't tell you that difference. So we're going to graph this. So using dashed lines. And do your best to make a U shape. I'm trying not to make this V shaped right here. It's kind of strangely shaped right here, so I'm fixing it. So that's pretty good. And then I put arrows. Always put arrows on the graphs when appropriate. All right, now we got to determine which way to shade. Now there's 2 ways to do this. One is I can look at this symbol right here. As long as y is on the left, I want y values to be greater than that expression, which says to me that if I'm standing here on this vertex, greater than is above. And so I would shade something like up here. All right. Now I'm going to shade a little better in a second. I'm going to show you another way to determine which way to shade, which you've probably seen before. But let's say that I want to just test a point. Now, don't test a point that's on the graph itself. So for instance, I would like to test 0, 0. It's always nice, but I can't because it's on my graph. So I'm going to try 1, 0, which is right here. Now, when I test 1, 0, I'm literally plugging into the inequality and seeing if it's true or false. So 0 for y, and then is that greater than 3 times 1 is 3, and then minus 6 times 1 is 6. Is it true or false? 0 greater than negative 3. Well, 0 is greater than negative 3. So since this is true, then I would shade from my graph in the direction of the true dot or point that I chose. So I would definitely still have shaded in the correct direction. So you can do it either way. So it's really all of this. Now I should not shade on the dashed line, and it just continues up in the upward kind of form of the parabola and on forever. Alright, so now let's answer a couple of these other questions. Try to keep this on the grid. Are the following points solutions to the above inequality? 1, 0. Well, that's interesting. I just tested 1, 0, but any point that's in the shaded region is a solution. So this is yes. All right. Negative 2, negative 1. Negative 2, negative 1 would be right here. Like, I'll put the dot. We're not really plotting these, but since those are that is outside of the shaded region, it's no. I'm going to go ahead and erase that because I don't want to think that that's part of the problem. And then how about 2, 0? Well, 2, 0 is right here. It's right on the dashed line. But if you're on a dashed line, you're not included in the solution. So this is also no. If it was on a solid line, then it would be a solution. All right, let's move on to the next problem. Graph the system of inequalities. Now, I'm going to do the same thing I did with the last problem. I'll go ahead and graph this first one right away. Go to y equals, clear what's in there, and I'll graph x squared plus 4x plus 1. I can go ahead and just hit graph now because I know my window's nice. All right, now we're going to graph this just like we did the last one. I might go a little quicker here to speed things up. I'm going to go second, calculate, number 2. I'm going to get the 0. It doesn't matter which one I get first. I'm going to go ahead and get the one to the left. So I think this is at 1, 2, 3. It's about negative 4, but I think it's a decimal. So my left bound, I'm going to choose negative 6. I could have chosen negative 5, I think, but negative 6 is conservative. Hit enter. My right bound, I'll go ahead and choose like negative 2. Enter. Guess. Don't worry about, just hit enter. All right, and there's one of them, negative 3.7. So I'm going to go ahead and graph that. And just estimate where that is. All right. Go back to the calculator, get the other one. Now, it looks like right around 0, so I'm going to go negative 1 for left bound. I'll use about 2 for the right bound. And then guess. I like that way better than scrolling. And it looks like negative 0.27, so really close to 0. I'm going to go ahead and graph that. So that's about right there. I'll go ahead and get the vertex. So second, calculate minimum because it opens up. So number 3. And then my left bound I can do about negative 4. Enter. My right bound I can just choose 0. Enter. Guess again, don't worry about it. And this is at negative 2, negative 3. So at negative 2, negative 3 I have that point. And we're going to go ahead and graph this. Comes down like this. Now, I chose dashed again because this doesn't have an equal to. So now I want to decide where to shade, and when I shade, since this is greater than, I could go ahead and shade greater than just by looking at it, whereas if your y value here, greater than is this way and less than is this way. However, I could also test a point, 0, 0, and 0, 0 is not on my line, so I'll test that real quick. 0 in for y, 0 in for x, and 0 in for x here, they drop out, is greater than 1. Is 0 greater than 1? Well, that's false, so then you would shade on the other side of the parabola. So if it's true, you shade in the region where the dot is. If it's false, you shade on the other side of the region. So then I'll shade in the inside. Now I'm using a highlighter, and sometimes this highlighter is tough. You are not supposed to shade outside the dashed region or on it, so I'm trying to be careful there. Alright, so that's your solution for the top inequality. Now the bottom one, we have to solve this for y. So I'm going to go ahead and do that over here. I've got negative 2y. I have to add the 2x squared to both sides. So greater than or equal to 2x squared plus 4x minus 2. Now I have to divide every single thing by negative 2. So divide this by negative 2. Everything divide by negative 2. And so this becomes y. Now remember, when we divide by a negative, we have to flip this inequality. So that gets flipped. This becomes negative x squared. This becomes negative 2x. And this becomes plus 1. Now we have to graph that. So we'll get our calculator here. We'll go to y equals. We'll clear what's in here and graph this one. So now this is negative x squared minus 2x plus 1. Now, you'll notice something different about this graph. All right? Now, I've got negative x squared minus 2x plus 1. This opens down. Now, I'm going to pause this, and I want you to graph it. I want you to graph the vertex and the x-intercepts, and when I come back, I'll have it completely graphed. Remember, when you graph this, this is a solid line, or a solid curve, I should say, because you have equal to there. Alright. Okay, hopefully your graph looks like this. You have x-intercept here, here, and a max this time. It opened down, so you use second calculate max. Remember, when you do left bound, then you do right bound. Then when it says guess, don't worry about that. Just hit enter, and you'll get your values. This should be a solid line because it was an equal to part. Now we got to determine how to shade. Now for speed purposes here, I'm just going to shade by looking at this. It says less than or equal to, so I want to shade inside here. If I'm standing on this vertex, going up would be greater than or equal to. Going down would be less than or equal to. You're perfectly welcome again to test any point in the coordinate plane to determine if you have a true or false, or to shade in what direction. So I'm going to shade with another color highlighter here, and the solution to this is where these two overlap. And so I'm going to try to be careful here again. Now notice that turned red because that overlaps there. So the purple is shading just the one inequality, the bottom, or the one that's inverted or upside down. Opens down is a good way to say that. I'm trying to be real careful and not shade outside the boundary because the highlighter on here tends to be a little bit of a problem. That's pretty good. Alright, so the purple region is overlapped here with the yellow region and makes the red. And so really the red is the solution. So you don't really have to write that, but for your notes, I'm just going to put a little arrow here. The solution is inside of here. Generally we don't write that. I'm just helping you out for your notes. So now, A, list one solution to the system. All we have to do is choose a nice ordered pair inside the red overlapping area. So how about negative 1, 0? And that'll do it. Anything inside that red red region, excuse me. I would be really careful. Don't choose a number on the boundary or an ordered pair on the boundary. On the boundary is actually okay as long as it's solid and also in the red region. On the dash line, you don't want to choose those. So I'd make it simple. So now, list an ordered pair that is not a solution to the system. You can choose anywhere outside the red region. Alright, so I could choose, I'm going to choose 6, 0 because it's no doubt that that's not a solution. All right, I could have chosen something in the yellow or the purple, but I just made it absolutely for sure. All right, have a good day.